Remember, to identify an angle, you do need to select 3 vertices, with the middle one, the second one that you select, being the vertex that you're choosing. So if I want to start with this vertex down here in the bottom left, I choose that as my second point, construct angle bisector. I can do the same thing from each of the other, or for each of the other angles. So now the angle on the bottom right, construct angle bisector, and then the upper left angle. Again, as you select it, choose 3 points, the second one being your vertex. And what you're going to see is those all intersect at a common point. This is referred to as the incenter. Okay. To designate that point, you can just choose the point tool. Now notice it only selects 2 of the lines at any given time. You can kind of make it change which 2. But it's not going to select all 3, even though it actually is the point where all 3 meet. You only need 2 elements to intersect in order to find that point, so that's how you will label it. Okay. And so the nice thing again with this is by using the dynamic software, no matter where you move these vertices of the triangle, that point, that incenter, will always stay at the point of intersection between the angle bisectors. Okay. Now there's one other thing that this point of concurrency does. An incenter also happens to be the center of a circle that's inscribed within the triangle. And so this also happens to be the center of a circle that can be inscribed within this triangle. What that means is that all 3 sides of the triangle would be tangent segments to the circle. And now, if you tried to eyeball this and make a circle that fit that condition, so if you were just to construct a circle where it intersected this line, is it guaranteed that that's going to stay inscribed as you move your figure around? So did it stay inscribed there? No. If you just try to eyeball it, it's not going to work. And so what you need to do is you need to tie it in. And the way that you can tie it in so that it works anytime you move the figure around is using properties of a circle at that tangent segment to help us. Now, what do you know happens when a circle is tangent to a segment? What properties exist? Josh?
Bisector, I guess.
So it would bisect the chord, right? It would be not bisector, but if you had a circle and the tangent segment at that point of tangency is going to intersect what part of the circle at what unique property? You guys remember from chapter 4? What does the radius and point and tangent segment intersect at? Nobody remembers? I remember, so I'll answer. And it intersects at a right angle. So remember, a radius and tangent intersect at a right angle. So we're going to use that property to find where the radius, or designate the radius of this triangle. Okay, so if we know it's going to intersect the side of this triangle, this tangent segment, at a perpendicular, you can choose the center point, the incenter, and choose one of the sides and construct a perpendicular through there. And now, in order to make sure that that's not confused with the angle bisectors, what I'm going to do is I'm going to select these angle bisectors, and I'm just going to turn them a lighter color. I'm going to turn them green so that they're kind of hidden behind.
How'd you do that?
Under display. So if you select it and go to display, you can change the colors. Okay, so here is my perpendicular segment. Okay, so if all I want is the portion of it that goes to this side of the triangle, I need to designate this point. I can either use the point tool and click on it, or I can highlight these 2 elements. Choose Control I to find the intersection. When the intersection is chosen, I can then click on the incenter as well use Control L to create that segment length, and this is the radius of my circle. And now, anytime you change colors of an element, it's going to stay that color. So this radius that I just drew is now green. I don't want it to be green. And so I'm going to go back to display, and I'll make this one blue now. And so the radius of my inscribed circle is now this blue segment. So I can hide. So if I deselect everything and click on the perpendicular that I use as my guide, I can hit Control H and hide that. And so now all I'm left with is this radius. But here's the radius that's perpendicular to my side. If I want to complete the entire inscribed circle, you can do a couple things. You can use the circle tool, and you can just drag it out to that intersection point. Or you can just highlight your center and your radius and use the construct command to create a circle by the center and radius, and it'll create that circle for you as well. And now as you move this around, no matter what, that circle will always stay inscribed within the triangle. Is there any place where the incenter is going to fall outside or lie outside the circle or lie outside the triangle? If we move it around, will we ever get that point to fall outside the circle? No, and it should make sense that that's the case, right? Because you're bisecting the angles, so it's always going to stay in between. So the incenter will always lie in the interior of the triangle. It's the point where the three angle bisectors of a triangle intersect each other, and it's the center of an inscribed circle, or a circle that's inscribed within that triangle.